Hey there guys, so in this video we're going to be looking at the K method substitution, and I have a few examples here for you today. So 5 to the power of 2x minus 6 times 5 to the power of x plus 5 is equal to 0. To start off this one, I'm going to write the first term a little bit differently. I'm going to write it as 5 to the power of x squared. The reason I'm doing this is so that I can substitute 5 to the power of x with k. So let me write that down. Let 5 to the power of x be equal to k. Okay, so now we have k squared minus 6k plus 5 equal to 0. Now that's your standard trinomial. So you can just go ahead and factorize here. K minus 5, k minus 1. And now you set each bracket equal to 0 and you solve k. So therefore k is equal to 5 and k is equal to 1. Now let's not forget that k was initially 5 to the power of x. So we're going to say 5 to the power of x equal to 5 and 5 to the power of x equal to 1. Now if 5 to the power of x is equal to 5 to the power of 1, then x is equal to 1. And if 5 to the power of x is equal to 1, we can write 1 as 5 to the power of 0. This means that x is equal to 0. Moving on to example number 2. This time we have 3 to the power of x plus 3 to the power of 2 minus x equal to 10. So first I want to break up my second term. I'm going to write that as 3 to the power of 2 times 3 to the power of negative x. Okay, so usually what I would do is I take out a common factor, but here we have 3 to the power of x and 3 to the power of negative x. And they are not alike, so I can't take out a common factor. So instead, I'm just going to simplify this a different way. So the 3 to the power of 2, I'm going to write as 9. And the 3 to the power of negative x, I'm going to write as 1 over 3 to the power of x. Okay, now I can just multiply those two terms. 9 times 1 over 3 to the power of x is 9 over 3 to the power of x. Okay, I think now is the appropriate time to do a k substitution. So let 3 to the power of x be equal to k. Now we can substitute k for 3 to the power of x. So therefore we have k plus 9 over k equal to 10. Okay, at this point now, since we have k as a denominator, I can multiply both sides by k. That leaves me with k squared plus 9, since the k's cancel, and 10k. Alright, again we have a trinomial, so let me just arrange everything. Bringing the 10k over, notice the sign changes, negative 10k, and now I can factorize. The factors of 9 to give me 10 would be 9 and 1. So k minus 9, k minus 1, and k is either equal to 9 or k is equal to 1. And again, let's remember that k was 3 to the power of x. So it's 3 to the power of x equal to 9 and 3 to the power of x equal to 1. 9 can be expressed as 3 squared, which then means that x is equal to 2. And 1 can be expressed as 3 to the power of 0, and therefore x is equal to 0. So remember, the goal here is we're always trying to make our bases the same so that our exponents can be equal. Okay, let's move on to question 3. Here we have the square root of 2x minus 1 minus 2 equal to 15 over the square root of 2x minus 1. Now this question already looks sus. It looks so complicated with all the square roots. But because the square root on the left hand side is identical to the square root on the right hand side, I'm just going to replace that with a k. So I'm going to say let the square root of 2x minus 1 be equal to k. And watch how we simplify this now. We now have k minus 2 equal to 15 over k. And this equation looks a lot more simpler than the one that you were just looking at. So let's solve this in the same way we did for the previous one. Multiply both sides by k. That gives me k squared minus 2k equal to 15. And at this point, you can now just take the 15 across. So you have k squared minus 2k minus 15 equal to 0. Factorize k minus 5 and k plus 3. And at this point, k is therefore either equal to 5 or k is equal to negative 3. Okay. Now, we know that the square root of 2x minus 1 has to be a positive number because in the original equation, it's represented as a positive number. So we know that k cannot be negative 3. So k can be equal to 5, but k cannot be equal to negative 3. So I'm just going to use the solution where k is equal to 5. Okay, so if k is equal to 5, then the square root of 2x minus 1 is equal to 5. And if we square both sides to solve x, then we have 2x minus 1. 5 squared is 25. You must carry the 1 over. So you have the 25 plus 1, which is 26. And then divide both sides by 2. And x is equal to 30. Okay, so well done if you got that answer. Now remember this, k substitution is not a necessity. It's just something we use to make an equation look more simpler than what it actually is. And once you've reduced the equation to a more simpler form, you can then replace k for what it originally was and solve the initial variable, which in this case was usually x. Okay, keep well, good luck.